My topic is milk does a body good, does milk do a plant good? I believe my topic is beneficial because milk can be used as a fertilizer. People would also use milk as a fertilizer for plants because milk can be used as an alternative option instead of water, and it is very popular now to be trying plant fertilizers. For my procedure, I use 6 mason jars for my plants to grow in. I filled my mason jars with organic soil and vermiculite. The vermiculite helps to aerate the soil. I planted the seeds and then used 3 different liquids to water each plant. The jars were labeled for each kind of liquid. The basil plants were watered with water and milk, and just milk. The cilantro plants were watered with water and milk, and just milk. Each plant was sprayed 13 times with the proper liquids every day. I took data and measured any plant growth. My results were the plants watered with just water sprouted and grew. The plants watered with water and milk sprouted a little later, but also grew. The plants watered with just milk did not grow, and the soil became hard, probably because of the casein, which can be used to make plastics. I investigated if milk can be a fertilizer for plants. Unfortunately, using just milk to water plants caused the soil to be too hard, and the seeds were unable to sprout past the top layer of the soil, so the plants watered with just milk never grew. The other liquids, water and milk, were able to grow. I suspect that milk can help a plant grow, but you can't just use milk to start off a plant. The plant must be past the top layer of soil for this to work. I also suspect that the plant needs more than just milk to grow. I think water is also essential to plants. How I began. I gathered my materials, which were organic potting soil, vermiculite to aerate the soil, 6 mason jars, labels, spray bottles, seeds for basil, seeds for cilantro, milk and water. Measured, mixed and filled the jars, labeled the jars in spray bottles, and planted the seeds. I put them in a sunny place and sprayed them with 3 different liquids. Some of them grew and some of them didn't. And grew some more. Then I charted the results. The, the blue represents the water, green represents water and milk, and red represents milk. The water obviously was the best, grew the best. The water and milk also sprouted, also grew. And the red, which is milk, never grew. So it's a flat line all across. Same thing with cilantro, same results. That's my presentation.
So I'm just going to get right into it. So my science fair project is about, is black ink really black ink? Now this has been a really big question for me throughout all my life, so I just wanted to answer it for once. So first is my abstract. Black ink can be broken down into its component colors. Even though black ink is black, what is actually in black ink? In my project, I proved that black ink isn't what it appears to be. I used paper chromatography to discover which colors really made up black ink. My materials are, I don't know if you could see it well, but if you look closely, 15 chromatography paper strips, which is actually right here. This is what they looked like. They're 15 inch. And usually I would have 15 of them, but here's just an example. Then I have a 100 milliliter beaker, which is right here, 100 milliliter. And then I have my 500 milliliter beaker. Again, I have my 90% isopropyl alcohol. I have 2 mini binder clips. I have 2 wooden splints, which is one is on the board. I have a black Sharpie marker, a washable black marker, a black ballpoint pen. I had scissors, pencil, water, plastic wrap, roller, and a notebook. And now, let's see the results. you can see that where it says Sharpie, purple, and where it says washable black marker, green and red, and it shot up. Okay, so as you can see, the results, it's not done yet, but here are the midway results. See how the middle on the marker turned green and red? But here's the thing, the dot disappeared. Look at that. The dot fully disappeared. And the Sharpie is bright purple. Okay, now I'm going to say my conclusion. My hypothesis was correct because the black ink turned into different colors. The experiment was fun to do, and I learned a lot from it.
Hello, my name is Mikey Gambino, and this is my science fair project, and it is, what's the fastest way to cool a soda? So I'm going to start on my abstract. Many people have the struggle of cooling their drinks down in a small amount of time. My experiment is to show the quickest way to cool a soda, so you won't have to worry anymore. People should care about my experiment because it's practical to want to cool your drinks quickly. It also demonstrates heat transfer, which is an extremely important concept in chemistry. I investigated this by putting 3 cans of soda in ice and 3 cans of soda in ice water. Then I timed the cooling of the soda and took precise measurements. The average time for the cans in the ice-only cooler was 59 minutes, and the average time for the cans to cool in ice water was 59.96 minutes. My experiment contributes to science because it teaches what heat transfer is. Okay, so I prepared 2 styrofoam cooler bath things, like 2 coolers, and I filled one with only ice, and I filled the other one with ice and water. And I had 6 cans of soda, and I put 3 in the ice only bath and 3 in the ice water bath.
Mhm.
And every 5 minutes I kept on checking the temperature on each can of soda, and I wrote it down. And we'll talk about that later with my data analysis. And I kept on doing it until I got the final results, which ice only or which bath reached equilibrium first with the cans. And what I got was for ice and water, the average temperature was only 56 minutes, and the ice only was 59 minutes. It tells us that the ice water bath cools down the soda quicker.
So I had to put the LEDs in, and then afterward I cut the glass to make sure it fit correctly, and then I taped and I put the glass on top, and I used tape to reinforce it. The lights from the LEDs bounce on the mirror, and then they bounce back on the glass, and because glass is reflected, it bounces back and it goes on for a while. It took me 2 days to make it. Like here, this is the process that it took. On my board, I needed to paint it, and then after I put the glass in, I painted it, and then I cut the glass here. So I'm cutting the glass here, and this is me. After I put the glass on and I taped it.
Awesome.
At first I had a problem when I got a smaller box, and I couldn't fit the correct glass. It was too small, so I had to get a different box, and I redid the project.
For my science fair project, I did our fingerprints inherited, and I did this science fair project because I was like, when I was younger, I looked at my fingerprints and I didn't know why there were whorls, loops, and arches, which are 3 different types of fingerprint formations on your fingerprints. When I was doing this project, I had 10 participants. I had 5 pairs of unrelated people, which were me, my sister, my 2 cousins, David and Nathan, Elise and Stella, Michael, John, and Connor and Luke, which if you can you see that in the back corner where it says right over here? This is where my data is. And those were the differences between the unrelated pairs and then the related pairs. So the ones that were half filled in were the ones that did not match. And out of everybody on the for the related pairs, 4 out of 5 of the pairs had matching fingerprints. And then for the unrelated side was Nalani Taylor, Antonia Juliana, Jonathan Gio, Ariana Catherine, and then Chris and Jack. So only 2 out of 5 of the pairs had matching fingerprints, and that was Chris, Jack, and Antonia and Juliana. Everybody else had different fingerprint formations. So for my procedure was what I had to do was rub a pencil on a 3 by 3 centimeter square of white printer paper, and I had to use wipes to clean the volunteer's right index finger for the graphite pad, which we made out of using the pencil. Then we had to use the wipes to ensure that the fingerprint was definitely clear. Then we had to thoroughly dry the index finger to make sure that we definitely got the correct fingerprint. Then we had to press the right index finger onto the graphite pad until the entire fingertip was covered in graphite. And then we had to roll the fingers onto a clear piece of tape and then observe the fingerprint so we'd be able to see what the fingerprint formation was. And we had to place the tape onto a piece of paper so we could be able to see it, correctly. And then once we were done, we had to put them on a chart, which was my pie chart, and that's what I did for the data and my procedure. My hypothesis is that fingerprints are not inherited from your parents because the only way you could have the exact same fingerprint are if you were an identical twin. So the hypothesis was wrong because I thought the only people who had the exact same fingerprints were identical twins. Most of my volunteers that had the same fingerprint formation, most of my related pairs had the same fingerprint formation. On the other hand, unrelated pairs matched fingerprints 2 out of 5 pairs. Therefore, my hypothesis was wrong. And that's my presentation.
So my science experiment was if plants can stop soil erosion. Soil erosion is a big deal. It is affecting farmers everywhere. I investigated this because I wanted to see if there were a way I could find that would help this big issue. I investigated whether the plants stopped soil erosion. I investigated this by doing my experiment, Can Plants Stop Soil Erosion? I planted seeds in a pan without seeds and one with seeds. After the plants grew, I tested this by tilting the two pans in the same angle and watered them to see how much water eroded out of them. The results were very clear. The pan with soil eroded 309 grams of soil. Meanwhile, the plants with seeds eroded 48 grams of soil. This conclusion showed plants really do stop soil erosion. This contributed a lot to the science because it shows people soil erosion doesn't just affect farmers, but it affects us too. The ground we stand on, the vegetables we eat, and the farmer's income, and lots of other things too. When we learn more about something, we can care more about something. Before I didn't really care about soil erosion. Since I've learned about this, it has made me care a lot more. So here is my science project that I'm about to present to you. All right. So my hypothesis, I believed that the roots would dig deep in the soil and will hold the soil together. The roots will stop and block the soil from eroding. The pans with seeds only leaked 48 grams of soil. Meanwhile, the pans without eroded 309 grams of soil.
That's a huge difference. Is that what's being shown on your graph, Nalani?
Yes.
That's a huge difference.
Yeah. In conclusion, my hypothesis is correct because the pan with seeds weighed less than the pan without seeds.
My project was, at what diameter does an aluminum boat sink? It's important because it helps people understand how ships float and how buoyant force works. It also helps them understand the Archimedes principle. I investigated this by cutting out a 25 centimeters piece of aluminum foil and squeezing until it was a certain diameter around in centimeters, and testing it in a bowl of water to see if it floats. The results I got for this experiment were that the smaller balls, 4.5, 4.7, and 5.1 diameter in centimeters, all completely sank, while the bigger balls, 6.2, 7.5, floated almost completely on top of the water, while 5.7 and 5.5, the mid-sized balls, were partially submerged. 7.5 was 47% underwater, 6.2 was 71.67% underwater, 5.1 and 4.7 and 4.5 were all 100% underwater. My experiment contributes to science by helping engineers design boats so they don't sink. When you pound the balls harder together, then the air pockets get squished out, and then it's just pure aluminum, and the density, it goes more than the water, and if it's more than the water, then it'll sink in the water. Well, these are my pictures. That's when I'm aluminum foil. That's the water and the Sharpie that I have. That's me measuring, recording my results, and testing again.
Do you want to tell them what this stuff is?
Oh, and that's my graph. The ball with that's biggest, it's less underwater than all the others.
My experiment was how does smell affect the sense of taste? It's true, smell does affect taste. I wanted to do my experiment because I always was curious how they work together. I was interested how taste and smell affected each other also. I thought of an interesting and fun experiment where I could test people and see if they can guess food without using their sense of smell. I thought that would be a good idea and a good way to see the connection between them. I also thought that I could do it because I use the sense of taste and smell every day. I wanted to understand them more and how we needed smell to taste food. My conclusion was My hypothesis was right because I said that the people that were blindfolded would not, and nose plugged, would not be able to tell what food they were tasting. When I tested my friends and family, every food, and they tasted, they did worse than the people who could smell. When I gave the sugar cookie, I got very different results than the other foods because sugar cookie doesn't have any scent, and when you eat it, part of your tongue has an area of sugar. So here are on my pie charts. So my Milky Way, all the people who I tested for blindfolded got it right, and for the nose plugged and blindfolded, 50% got that right and wrong. So the blue is right and the red is wrong. The sugar cookie, like I said, I got different results. One person got it wrong from blindfold, and everyone got it right from blindfolded and nose plugged. My Jolly Ranchers, it was 50-50 for blindfolded people, so 2 people got it right and 2 people got it wrong. For blindfolded and nose plugged, I got 3 people got it wrong and 1 person got it right for the Jolly Ranchers. For the orange juice, everyone got it right, it was blindfolded. For the blindfolded and nose plugged, everyone got it right except 1 person. For the snickerdoodles, everyone got it right that was blindfolded. It was 50-50 for blindfolded and nose plugged. Pineapple was everyone who was blindfolded got 1 right and wrong, and 3 people got it right. And 1 person got it wrong for blindfolded and nose plugged. My snickerdoodle, everyone got that right for blindfolded, and for blindfolded and nose plugged was 50-50. And then I have my pictures. Here. That's it.
Okay, my science fair question is, can you turn milk into plastic? My science fair project is important because it is a healthier way to make plastic and it's biodegradable. Also, there is currently an act to make plastic in a healthier way for the environment. My problem is I want to find a better way to make plastic. Can everyone hear me? The way I did this was by making milk plastic. I made milk plastic by boiling 1 cup of milk, adding 4 tablespoons of vinegar, mixing them, and it made milk plastic. After I did this, I found out that 10.96% of milk is plastic, or protein. I think that I have accomplished what I tried to do in this experiment. My experiment contributes to science by finding a healthier alternative to making plastic. My hypothesis. I believe that it is possible for milk to turn into plastic because milk contains casein, and casein contains monomers, and I think that when you boil the milk, it'll break down and release monomers, and that will form polymers, and will make plastic. My conclusion. I have recently done my experiment, and it turned out that my hypothesis is correct. I was right about my experiment because when I put the vinegar in the milk, it broke down the solids and made plastic. Another reason that my hypothesis was correct is because it turns out that 10.96 of milk is milk plastic. That's it.
My experiment is, can you detect if someone is lying by body movement? I think my experiment is important because it can help investigate crimes by testing the person who is guilty if he or she is lying. I used simple materials that were paper and some volunteers. Throughout my experiment, I found out when a person lies, they usually have certain body movements that make them sweat or get weaker. While I was experimenting, I got a result of 92%
95.2%. This percentages were all of the times where I can detect whether my volunteer was lying or not, and only 4.76% of the time I couldn't detect when they were lying. I chose this experiment because I have always wanted to find out how the brain works and all of its functions. So I decided to use this as my experiment. First, as my procedure, I had a volunteer write down 2 things that they like and 1 thing that they don't. I had the volunteer stand in front of me with their arm up and their palm facing down. The volunteer would tell me would tell me whatever they wrote down and tell me that they like all of those things even if they don't. After they say their phrase, I will extend my arm and press down on theirs, creating resistance. Depending on how weak or strong their arm is, I could tell whether they were lying or not. These graphs are every time where I tested my experiment on a volunteer, how many times I could detect when they were lying. So for the ones that show 100% was that each time, every single time that I tested on them, I detect if they were lying or not.
So my science experiment is whether you can differentiate different types of background radiation in a cloud chamber.
Mm-hmm.
Background radiation is the natural existing radiation in an area. The cloud chamber was invented by Charles Thomson Rees-Wilson in 1894. Okay. A cloud chamber is a sealed container that's saturated with alcohol. The top of the cloud chamber, there's felt at the top of the cloud chamber, and I would put alcohol in the cloud chamber. And at the top, I would put my hand to heat the top, and then in the pan at the bottom, there would be dry ice to cool the cloud chamber, making a temperature gradient. That would cause mist to form in the cloud chamber, and as the radiation passes through, the radiation would knock off the alcohol molecules, creating tracks showing where the radiation was, the trails of the radiation. When I first tried the experiment, it took 15 minutes to assemble the cloud chamber, and when I tried it, there was barely any mist and there was no radiation inside the cloud chamber. It was the same results for the second, and on the third try, there was minimum mist inside the cloud chamber. But on the fourth try, when I did it at school, there was a lot of mist in there, and we had to actually turn it upside down in order to show the mist. I tried different ways of doing it. I tried changing the background, and it just didn't work. And I was thinking that it could have been the dry ice. The dry ice couldn't have been genuine in order for the cloud chamber to work. So in conclusion, my science experiment didn't work.
My science fair question is, does temperature affect the strength of a magnet? The purpose of my project was to see if temperature affects the strength of magnets. I tested this by putting a magnet in room temperature water and seeing how many paper clips it picked up. Then I put a magnet in boiling hot water and saw how many paper clips it picked up. And then I put it in cold water and saw how many paper clips it picked up. These are the results of the magnets that I picked up.
So can you read that off to us, please?
What?
Can you read that off to us, please? Like how many?
So the normal magnet picked up 100 paper clips. The hot one picked up 34, and the cold one picked up 64. My hypothesis was I think that heating up the magnets will affect the strength of a magnet because heating up a magnet makes the molecules inside move fast, and that disturbs the strength, disturbs the south and north pole, which will weaken the magnet. My hypothesis was correct because the hot magnet picked up 34 paper clips and the normal magnet picked up 100. In conclusion, temperature does affect the strength of a magnet.
So jumping right into it, I'm going to start with my abstract. So my experiment is the science of mummification. How does baking soda affect meats? My experiment is important because it shows the best substances to preserve meats. For example, the hot dog that was put in baking powder. You could see it in the graph. It's the third one. It shrunk the most. So it started at 12.8 on the top.
12.8 what?
12.8 centimeters.
Thank you.
And in the next week, it was 10.5 centimeters. The third week, it was 10.2 centimeters.
So why are the hot dogs shrinking?
Because the baking powder, baking soda, all of the substances, I forget what it's called.
Hydrate, right?
Yeah, dehydrated it and pushed the water out of the hot dog cells.
So dehydration, you're saying, is that the water actually gets pushed out of the cells?
Yes.
So that's why they're shrinking now.
Yes. So the hot dog in baking powder was the best substance of shrinking wise, but the worst substance is the control hot dog. The control hot dog did not shrink nearly as much. That's always the first one on the graphs. So the hot dog started at 12.8 like every other hot dog. And in the next 10 days, it only shrunk to 12.6 centimeters. The next week, the third week, it only shrunk to 12.4 centimeters. And also it got very, very moldy, and it was very stinky. So if you're gonna preserve meats, don't just leave them out in the open because it'll just rot up your house.
So my experiment is what materials can block a Wi-Fi signal. So my abstract is that my experiment was about what materials can block a Wi-Fi signal. It is important because it can show what materials give the most interference to your internet. My experiment is also important because almost everything from smartphones to life support electronics use Wi-Fi. And if the Wi-Fi was shut down, it would be very severe to people around the world. I investigated what materials block Wi-Fi signals the most. I investigated this by placing each material between the router and the receiver. The plastic had the highest average dBm of negative 60.3, which means it caused a lot of interference. And when nothing was between the router and the receiver, it had the lowest average dBm of negative 44, which means it caused the least interference. My experiment shows how different materials can affect your Wi-Fi signal. I chose this experiment because I really like technology and computers. And this experiment was about Wi-Fi signals, how they work, and what interferes with them. My hypothesis is, I believe that materials made of metal can block a Wi-Fi signal. I believe this because metal objects can reflect and absorb radio waves, and Wi-Fi signals use radio waves. So the first one that caused the least interference, like I said, was nothing between the Wi-Fi signal and the router. And the average was negative 44 dBm. The second material that caused the least interference was a glass pan with an average of negative 45 dBm. The material that caused the most interference was plastic with an average of negative 60.3 dBm. And the next material that causes the most interference was the human body with an average of negative 54.3 dBm. And my conclusion. My hypothesis was partially correct because even though the aluminum foil's average dBm was very high with an average of 54 dBm and shows that the aluminum foil blocked the Wi-Fi signal, in my hypothesis, I stated that only metal could stop the Wi-Fi signal, and that was proven incorrect, and the plastic's average dBm was higher than the aluminum foil. I think the plastic was so effective because of the natural materials inside of the plastic, like coal, salt, and natural gas. I think my science fair project was good.
My science fair project is about which drink conducts the most electricity or which drink has the most electrolytes. But what are electrolytes? An electrolyte is a substance that conducts electricity when dissolved in water. Some common electrolytes in your body are sodium, chloride, potassium, magnetism, calcium, and phosphate. Electricity kind of sounds like electrolytes, and they're similar. Electricity is a type of energy that flows from one place to another, like this circuit, for example. This circuit has this battery. It starts from the battery. This battery has electrolytes in it. It has zinc, potassium, and manganese. And there's two parts of there's two wires. There's the negatively charged particles, it's the black wire, and the positively charged particles is the red wire. And it goes in the system. It starts from the negatively charged particles back up to the positively charged particles in a cycle. This circuit works by the black wires going through the green wires. If there was a drink, if you would put this in a drink, the drink would connect these two copper wires through the black wires into the multimeter, through the multimeter back to the battery, and it would go through the system. This won't work if you don't have a drink. Like right now, I don't have a drink in the straw because the straw is not, the copper wires are not connected to anything. So, if I put a drink in here, say apple juice, it would go through the straw, through the black wires, and it would measure, 25 milliamps. That's what we're measuring, and it would be 25 milliamps, and that will show how much electrolytes it has because it will show how much electrolytes it has because electricity is very similar to electrolytes. And the apple juice is conducting the electricity, and it would see how well it would go through this circuit. And that's my project.
Hi, my name is Jack Science, and I will be presenting my 6th grade science fair project. My science fair project is, can you turn a liquid into a solid without a freezing point? And you actually can. With the process called spherification. It's a process in which you turn liquid into a solid that is edible. And I'll tell you a little bit about it. So, purification is the science of cooking. It's cooking and food science. And there's the one made out of water. There's the Coke one. It does not look very appetizing. Now, the weird thing about the Kool-Aid one is that it
didn't turn into Kool-Aid, right?
It did not spherify at all. And it actually turned into a chip. So, with the process of spherification, you the main key ingredient is sodium alginate, which is a thickening agent, which will help water gel. And
it has a natural source, though, right? Like, where is sodium alginate found usually?
You find it in natural brines and seaweed.
Interesting. So you find it in seaweed.
Yes, and this helps gel liquids or even sometimes food. But calcium chloride helps it gel a lot faster. Without calcium chloride, I don't even think it would work.
Do you know what the calcium chloride does?
Calcium chloride is usually used like those ice pellets they use on the road, so to slow down roads and like on sidewalks. It looks like you eat them, you sort of have to expect it to not taste amazing. The water one tasted okay, but the Coke did not taste good at all. It was really, really bad. It was like a black licorice and expired Coke. That's what it tasted like.
Yeah, it doesn't sound great.
All right, I'll tell you my procedure now. So I put 1 cup of water in a bowl, and I added 2 ounces of calcium chloride and mix it until it dissolves. I put saran wrap over the bowl so it could sit. Then I took 1/4 of a cup of the liquid I use, example Coke or water, and blended it. And I put it in blended. And then while it was blending, I added 2 ounces of sodium alginate. And then you blend it for 1 minute. And then the liquid in it if you feel it, it sort of feels like slime.
Mm.
And then once you have that, you pour the liquid into a bowl. Then you add sodium citrate to it, but you don't do that for water because it has no acidity.
Right. You don't have to change the pH on that one.
Yeah. So then you take the syringe and suck up a little bit of the liquid that has the sodium alginate and sodium citrate in it and gently place it in the bowl that has the dissolved calcium chloride and wait 1 minute and take it out, and then you have a juice ball. And you know what? I'll eat one right now. I'll give you a little.
Jack to be hamming up the show. There it is.
It tastes like water.
So my question is, can a potato be used as a battery? My abstract. The reason why my project should be carried in real life is because batteries are important things to work. Batteries are used in a lot of everyday appliances and objects that we use every day. Clocks, remote controls, watches, our phones, and of course, they're also manual, but not using battery items that can do the same thing, except car batteries. They make a lot easier for everyone. I think my project should be used in real life because if you have a dead battery and you need a device with a specific battery, you can make a homemade potato battery that the device that you want charged until you replace the specific battery.
How can you make a potato batter, you ask? Well, it's easy. First, get a fresh potato. Get 1 4-inch copper ion and 1 4-inch zinc ion. Place the ion strips around about 1 inch apart through a potato. Turn on a multimeter, connect the wires to the multimeter, connect the alligator clips onto the zinc and copper ions to the item you want to charge. For example, you would connect the alligator clips to an LED light to produce a light source. Potato batteries are not as strong as regular batteries, so the light wouldn't be very bright. My problem statement was if you can make a battery out of a potato and do tasks with it. I observed that my potato produces less energy as the days go on. On the first day, the results for how much electricity the potato produced was 0.91 volts. The second day, the potato produced 0.51 volts. And then the third day, the potato produced 0.31 volts. In conclusion, my project contributes to the science because potatoes conduct electricity. Almost any fruit or vegetable can conduct electricity.
This is how I built my levitator. And first thing, I started off with testing each one of these ultrasonic speakers. And then we had to hot glue them to the frame of here, all 72 of them. And then we had to wrap copper wire around the positive and negative legs right here. And then next we had to solder wires to each and not to each and every one, but to the positive and negative one. Positive and negative wire right there, attaching to the negative legs of the thing. Same with the bottom here. And then we had to connect that to the chip that regulates the voltage so it doesn't blow up the entire model. And then we had to program an Arduino right here. So the Arduino works all 72 of these to do the same thing. And we had that all wired up to here too. And then once we powered it, like we'll do right here, we will take a styrofoam ball, right? We'll place it right in the middle of the levitator. And bada bing, bada boom, you just built a levitator.